Yeah, hello everyone, it's Jason again. So yeah, this time I'm here to help present this paper, GPTVoiceTasker, which is a system that uses LLM technology to execute voice commands on mobile applications. And again, I'm presenting these slides on behalf of the authors, Min Duc, I believe Dustin Vu, Han Wang, Zhuang Li, Jieshan Chen, Shendong Zhao, Zhen Changxing, and Chunyang Chen. And yeah, unfortunately, due to some unforeseen circumstances, they weren't able to make it to UIST, but I think this work is really interesting, and I'm happy to help talk about it today. So there are going to be a couple parts to this talk. So first, we're going to talk about the motivation of why we would want a capable voice-driven agent for mobile devices. Then the talk is going to dive into how the system works and show a video demo of it in action. The authors also ran several evaluations where they measured the performance of their system against baselines. And finally, the talk is going to conclude on some discussion points. So first, why would we want a capable voice assistant? So voice control technology has this huge potential to improve how we interact with smartphones, especially in situations where manual input is inconvenient. So these are like situational impairments and also for people with accessibility needs. And major assistants like Siri and Google Assistant have brought voice interaction to millions of people, but they still face critical limitations. So first, they struggle with more complex tasks and queries that a user might have. And one of the reasons for this is that these existing systems are built around predefined commands that aren't really meant to generalize to user inputs that fall outside of that program's scope. So for example, you can search for videos on YouTube using a voice command that's supported, but if you want to access video history or some other complex actions, those are not supported. And furthermore, the burden is actually on app developers to manually define those voice-supported actions. And in addition to being a lot of work, this affects the flexibility of what the system can understand and execute. So developers need to predict beforehand a wide range of user intents, and this is really challenging. So therefore, all of this points to this need for a voice-controlled assistant that can interpret user needs intelligently and also directly control mobile devices. So in this work, the authors introduced GPTVoiceTasker. GPTVoiceTasker provides a novel, intuitive method for automating complex commands on smartphones during, for example, situational impairments. And to support this, the system can, number one, explore apps in real time using step-by-step interactions suggested by an LLM. And in addition to this, the system also saves information during its explorations that can be drawn on in the future to accelerate automation processes for similar tasks. So upon receiving what's called an unprecedented task from a user, so this means the LLM hasn't seen something like this before, GPTVoiceTasker the system hasn't seen this before. The GPTVoiceTasker will progressively predict and automatically execute each task using an LLM until it thinks the task is accomplished. So during each step here, the system collects a variety of contextual information to construct a specifically formatted prompt that a large language model uses to predict the most appropriate action. And again, GPTVoiceTasker both executes this action on the smartphone and also saves the sequence of interactions for later usage. To give more information about the prompt creation, this figure demonstrates the format which was used to select the most relevant target for tapping elements. The prompt contains the task details, the user's command, application information, UI elements, and an exemplar with a sample prompt and response. And to further improve accuracy, the system employs techniques like least to most prompting to break tasks into smaller steps, and also few-shot prompting with chain of thought reasoning for better logic. So for tasks that the user has previously executed, the authors again call these precedented tasks. GPTVoiceTasker incorporates this previously seen data using dynamic pathfinding. So we can walk through an example of where a user here wants to order spaghetti through Uber Eats. And the system first understands what is the current screen that we're on, and it generates a description of the current screen elements and also text. So in this case, it would contain things like pizza and Thai. And the system, once the system has ID'd the current screen, it can use this to look for similar tasks and screens in its database. So here we can see that there's actually a previous user command about like, I want to order some sushi, and that corresponds to screen ID 4. So the system can recognize this similar task and prepare to replicate that path. And it does this using a shortest path algorithm to automate the user's interactions based on previous traces. And there's also a technique that they use called parameter substitution. So this technique allows the system to reuse a similar saved task. So here it was like for sushi, but it'll automatically substitute sushi for spaghetti. And this flexibility is really what allows it to handle a much larger range of user requests without manually needing to define a new one. So here's a short video demo of a user using GPTVoiceTasker to operate a home workout app. Forgot to plug this in.
First, we demonstrate the first time we are using the app to search for the plank exercise. I want to see how to do the plank exercise. In here, the large language model predicts my intention and performs step-by-step on-screen execution to get to the destination screen showing the plank exercise. With this task is completed, GPTVoiceTasker also saves the task for later usage. Show me how to do a chin-up exercise. As you can see here, the speed of execution is improved because the task has been saved previously for the plank exercise. Now the step is applied for the chin exercise. That's all for our demo. Thank you so much for listening.
So how well does the system work? The authors conducted a couple of evaluations where each focused on a different component or capability of their system. So the first one is what they refer to as on-screen interaction. So this focuses on pretty much how well the unprecedented module handles commands related to interactions on a single screen. So the authors constructed a specialized test set of 278 samples, which contained ground truth mappings of the tasks and corresponding actions. And they adopted several baselines and metrics. So these metrics were exact match accuracy, which means that the system got the entire ground truth sequence correctly, and then the target F1 and action F1 scores refer to the accuracy that the correct target and actions were chosen at each step. So as you can see here, GPTVoiceTasker outperforms all baselines across all metrics, so it achieved 84.7% exact match, 91.7 action F1 score, and 84.7 target F1 score. The authors... Whoa. The authors also conducted another related evaluation for the unprecedented module, but this was focused more on multi-step interactions beyond single screen. So authors chose to use 140 sample demonstrations and commands from Android into Wild, and these provide step-by-step interactions, again, spanning multiple screens. The main baseline here was a system by Wang et al., which used two-shot prompting with GPT-4. And the main result here was that GPTVoiceTasker could achieve a 85.7% success rate. And it out. I didn't touch it. Yeah, I didn't touch anything. Okay. And it outperformed the baseline, which only had a 56.4% success rate. Try a new port, possibly. Okay. The authors performed another experiment that assessed the system performance on precedented tasks. So again, this is retrieving previously seen relevant traces. So it evaluated GPTVoiceTasker's ability to automate tasks using popular smartphone apps. And here the authors created direct match and parameterized tasks across 5 categories. So this means direct match is like an exactly repeated command, like is it able to replay that? And then there's also one that's like a parameterized task which requires like substitution. So get directions to the nearest supermarket becomes like nearest restaurant. So GPTVoiceTasker successfully completed 82.7% exact match tasks and 72% parameterized one, showing the strongest results in messaging and direction apps. And actually, the more challenging scenarios were with alarm and settings tasks due to the additional complexity in UI elements and also some unexpected pop-ups here. So finally, the authors conducted a user study comparing its usability with Google Voice Access and Voicify. So they had 18 participants perform tasks using all three tools, and the participants ages 18 to 31 had some prior smartphone experience, but not too much familiarity with voice control systems. Okay, so here the authors recorded task completion times and gathered feedback with the SUS and TLX scales to compare against baselines. There were a couple of takeaways here. So first, GPTVoiceTasker clearly outperformed others in terms of speed, and this efficiency stems from its ability to interpret user commands accurately and also leverage the previously saved commands. And participants also rated it much better in terms of ease of use and frequency of use and being easier to learn. So feedback revealed, again, less mental and physical effort, and people reported lower cognitive loads and increased and higher performance satisfaction. So please check out the paper for more details. The authors wanted to conclude here on some discussion points. The first thing is the system's improved performance could really increase the adoption of voice-centric interfaces, which we said earlier has many benefits. LLMs were also instrumental in getting the performance to where it is, by converting complex visual interfaces into prompts that can be reasoned over. So currently they're using a text representation, but future work could use multimodality. And of course, an important thing to do in the future is making sure the system is used responsibly in terms of privacy and getting the system to generalize better across different device form factors like smartwatches. And yeah, this is all for this project. If you want to learn more, there's this website about the project here, I think magna.io. Do we have, yeah, I think that's it. Okay.